lesson today, what we're going to be looking at is something we haven't gone over yet in pre-algebra, solving inequalities by using addition or subtraction. Let's start the way we always do by going over our 3 vocabulary words. Our first one is inequality. An inequality is a statement formed by placing an inequality symbol between 2 expressions. You have seen these inequality symbols before, actually, since you were quite young. We call them the greater than and less than sign. What we're going to do now, though, in this lesson is apply them to variable expressions. We'll be looking at math that looks very much like solving equations that we have been doing for the past several lessons. What we're doing instead is we're replacing that equal sign with a greater than or a less than symbol. Our second vocabulary word is a solution. The solution is the set of numbers that make an inequality true. Now, up until now, when we've been working with equations, we've really only had one possible answer, one correct answer. Once in a while, we saw that we would have an equation that had no solution, and then even once or twice in class, we saw an equation that had an infinite number of solutions. Here what we see, this word that I want to draw your attention to, set. When we're working with inequalities, what we have is an entire range of numbers. And then 3, an equivalent inequality. They're basically 2 inequalities that have the same solution. Now, one piece that's different between solving inequalities and solving equations is that there is a second thing that we have to do called graphing the inequality, and that's what we're going to look at on the next board. So if you see here, what we're going to do now is graph these inequalities. So typically what will happen is we'll have a variable and you'll end up with a single number on the other side of the inequality symbol. And then what we're going to do is graph. This inequality says x is greater than 4. So what I did was I drew up a number line of sorts. And I just put the number 4 on it. Now what we're saying is that for a given equation, x, all the possible numbers that would make this inequality true means that every number is greater than 4. What we do is we put an open circle over the number 4 on our number line. And to show x is greater than 4, we make our own arrow to the right, because all these numbers here, 5, 6, 7, 8, into infinity, are greater than 4. Now let's take a look at this symbol. This symbol is new. This says greater than or equal to. This is a little bit different. See here, where x is greater than 4, the number 4 is not included in the solution. But here, this bar underneath the inequality symbol means that the negative 3 is actually part of the solution. So the way we show that is to draw our circle and then color it in. So the colored in circle means that a negative 3 is part of our solution set. And again, we're working with greater than, so we show our numbers. We'll draw our arrow here again to the right, because all the numbers to the right of negative 3 on the number line are greater than it. And now we have 2 less than inequality statements. Here we have x is less than negative 12. So here I have our our negative 12 on the number line. Because the numbers are less than, I have an open circle over our negative 12. And then our arrow will go to the left, because on a number line, all the numbers to the left are less than the number that we're looking at. And then if you look at our last example, x is less than or equal to 9. It means that after we draw our circle above our 9, we have to color it in to show that 9 is part of the solution set. every number in our solution is less than, so we draw our arrow to the left. So when you see in your directions, or if you hear me say to graph your solution after you find it, this is the kind of graph that we're talking about. Now it's time to go on to the first of our 3 examples. Let's take a look at the problem. We have a negative 14 is greater than 12 minus x minus 18. And what we have to do is find out if a positive 11 makes this statement true. We want to see if a positive 11 is in the solution. So we're going to solve this the way we have solved equations, in that we're going to rewrite the inequality, and this time we're going to substitute our positive 11 for our x. That means we're going to write negative 14 is greater than 12 minus, and instead of writing x, remember, we're substituting our 11 minus 18. And now all we have to do is simplify by combining these terms. So we have a 12 and a negative 11, and together they make a positive 1. A positive 1 paired with a negative 18 make a negative 17. And now that we're done, we can reread our statement to see if it is true or not. A negative 14 is greater than negative 17. This is a true statement, so the answer is yes. Positive 11 is in the solution set to this inequality. Now let's take a look at our example 2. Here what we're going to do is solve the inequality and then graph it. Here we have 5.3 plus m is greater than a negative 4.8. What's good about working with inequalities is that you already have all the skills you need in order to do this. We're going to treat this as if it was an equation. What I mean by that is, what our goal is to get the m by itself. We want to isolate this variable. We have to take a look at it and see that right now, it's not alone. It's being kept company by positive 5.3. And so what we're going to do is use inverse operations to negate this constant. The opposite of a positive 5.3 is a negative 5.3. And just like in an equation, we have to do it to both sides. So that we are going to write our expression, and this time apply our negative 5.3 is greater than negative 4.8, negative 5.3. The positive 5.3 and the negative 5.3 make a 0. That leaves us with an m. M is greater than. Now we combine our terms, a negative 4.8 and a negative 5.3 together make a negative 10.1. And now what we're going to do is graph our inequality. We have to graph our solution. So we'll make a number line. And we'll put on it a negative 10.1. And we see that m is greater than negative 10.1. Greater than means we keep an open circle above that number. Since every number in the solution set is greater than a negative 10.1, we make our new arrow moving toward the right because it's in this part of the number line. The numbers are greater than a negative 10.1. And now we have only one more example. Here we have a word problem. You're shopping for a new outfit and your budget is $50. You see a shirt that you like and it's on sale for $15.95. Write and solve an inequality that shows the most that you may spend on a pair of pants. So we're going to use the information in this problem to write an inequality, and then we're going to solve it. And here's how we look at a question like this. I like to start with our total. We know that we have $50 to spend. We also know that we have a shirt that we're going to buy that is $15.95, and we're going to buy a pair of pants. And notice I left this area open. Here is where we have to put our inequality symbol. But I want to talk about how we know what kind to use. We know that $50 is the most that you can spend, which means that anything we spend has to be less than the $50. I'm sorry. We know that the $50 is going to be this $15.95, and the pair of pants has to be less than $50 because we can't go higher, but we can spend the entire amount. So we're going to add that bar to show that the money that we spent on our outfit has to be either less than 50 or equal to it. We cannot go above it. And now what we're going to do is solve for P. That will tell us how much we can spend on our pants. Right now, P has a positive 15.95 with it, so we're going to put a negative 15.95 on both sides. So we have 50 minus 15.95 is greater than or equal to. I'm going to do the same thing on this side. When we have our subtraction here, we have 50 minus 15.95, and that gives us 34.05 is greater than or equal to this positive and negative 15.95 cancel each other out, and we get our P. And so because this is a word problem, our final answer will be in a complete sentence. And our answer is that if we buy a shirt for $15.95, we can spend up to $34.05 for our pair of pants. Then you'll have a complete outfit. And so now you have a little bit of an understanding of what an inequality is. And then next class, we'll go over this more deeply.